Good morning, Tamina Khan is here in TKMaths S1. In today's video, we will continue the lessons of A-Level Mathematics M1, lesson number 2, which is on distance, velocity and acceleration. This video is on the last concept of this lesson, which is based on the past paper question. I have picked up two past paper questions, June 24 variant 4.1 question 1 and November 18 variant 4.2 question 3. After that, this lesson will be completed and we will start with the next lesson, which is the use of calculus. And in the description, I am putting the link of the playlist of all the videos I will put in this lesson, in these lessons of M1. So it will be easy for you to access from there for the rest of the lessons. So let's start with this question. A car starts from rest and accelerates at 2 meters per second square for 10 seconds. It then travels at a constant speed for 30 seconds. The car then uniformly decelerates to rest over a period of 20 seconds. So let's see, suppose, first of all, I have to label here. So this is time. It is t seconds, you can write, or t, your choice. And this is velocity is v meter per second. So first of all, it is for 10 seconds. And after that, for 30 seconds, to 10 plus 30 is 40. And then after that, for 20-second period, so 20 plus 40 is 60. Now, it is accelerating for 2 meters per second. So what was the velocity here? Suppose it has come till here. So, and then after that, it continues with the constant speed. We'll find out this velocity in a second. And then it decelerates. Right. Now, if you see the steepness of the third stage is less than the steepness of the first stage, nothing is mentioned there, but it was written here, it was taking 20 seconds to decelerate and 10 seconds to accelerate. It means speed is fast there, right? So now, just a second, I have to find out this velocity. Now, what is the way to figure it out? It's very easy. I will tell you a very basic one. Because you know that what it is called, the gradient, right? So the gradient is basically the acceleration. In the velocity time graph, the gradient gives you acceleration. So this acceleration is 2 meters per second square. So if I see at this point, which is the starting point, the coordinates are 0, 0, and here it is 10, v. So if you apply the gradient formula, you can easily calculate it very quickly, v minus 0 over 10 minus 0. And secondly, mentally also you can do it very easily. But sometimes students still get confused, so that's why I have shown the working here. So that's why you can write here the velocity is 20. Okay, so this is how you will sketch it completely. Find the total distance covered by the car. In the velocity time graph, the area under the curve is basically your distance, right? So this is the shape of the trapezium. You can apply the formula for the area of trapezium, which will give you the distance covered by the car in this journey. So area is the distance which we have to calculate. Okay, so height is the perpendicular distance between two parallel sides. So these sides are parallel. So this height is 20 and A and B are parallel sides. So it is 60 plus 30. So you can solve it. You have a calculator. So it will be 6, 7, 8, 9, 900 meters. So I hope you understood and you have easily done it also. Now, if you want to give or put the video on pause and want to try out yourself, you can. So now in this question, the velocity of the particle, now sketch is given to you, right? So basically mostly sketch is asked to draw or sometime it is already given to you. The velocity of particle moving in a straight line is v meter per second at time t second. The diagram shows a velocity time graph which models the motion of the particle from 0 second to t second. This is the complete time. The graph consists of 4 straight line segments, 1, 2, 3, 4. Okay, so it consists of 4 straight segments. The particle reaches its maximum velocity v in 10 seconds. Find the acceleration of the particle during the first 2 seconds. Again, acceleration is the gradient. So if I see here, the point here is 0, 0. The point here is 2, -2. And my acceleration will be easily calculated. You can do directly also. So I will apply gradient formula. Okay, so it is, -1 meter per second square. Okay, so after that, question is saying find the value of v. Now to find the value of v, just a minute. Okay, value of v, what comes in your mind? No other information is given here. Again, the same concept. This line from here till here has the same gradient, right? And I know 3 points on it. This is 4, -2. This point is 6, 0. And this point is 10, v. So I will apply the gradient on first these 2 points. And after that, I will apply gradient on these 2 and equate them, right? So I can say, suppose let me apply here. One point is 4 -2, then 6, 0, and then 10 and v. So let's do it very quickly. y2 minus y1 over x2 minus x1. You can check the calculation. I hope there will be no mistake. It's very simple. And I will tell you one thing here, which is very interesting. What did I get here? 1, right? Now, if you notice here, in part 1, we found here the gradient of this part was 1, right? So similarly, it would be 1. What is the reason? Because it is symmetric. I will say same slant. Reason is 2 seconds here, 2 seconds here, 2 seconds here. So that's why the gradient will be same magnitude but with opposite sign. So without doing anything also, I could use it directly, but just to show you, I have done this here. Okay, so now it will be v over 4. So v is equals to 4 meter per second. So I have found the value of v here, which is 4 meter per second. Okay, so now we have to, so we have found this value, it is 4. And this acceleration is -1 and this is 1. Now question is saying at time t equals to 6, which is this time, the particle is instantaneously at rest at the point A. So when particle covers 6 seconds, it is at the point which is called A. And after that, at time t equals to t, the particle comes to rest again at B. So this part is called B. At t equals to 0, the particle starts from rest. So we know the particle's journey started from here. This distance, which is covered between 0 to A, right, initially, is 1/3 of the distance which is covered here. So this distance is 1/3 of this one. So I can say this is 3 times of this distance. Agreed? So this is a very important information for us. So to find out the value of t here, first of all, I'll find out the distance here in this whole portion, so that I can multiply it by 3 and get this distance. Okay, so let's do it. So distance covered from 0 to A time. What is the shape? Trapezium. So let's apply the trapezium formula. Achha, by the way, this minus sign is just telling the direction. When you are calculating distance or area under the curve, you don't need to mention it here, right? So now it is 6 plus 2. Okay, so distance covered is 8 meter. So similarly, distance covered from A to B is equals to 8 times of 3, because this is 1/3, so that is 3 times of it, so 24 meter. So after that, it is very easy to calculate t. Let me call this base as small t. Okay, so I can say the distance or the area is equals to half into t into 4, and that is equals to what? 24. So you will get 12. So this whole thing is 12 because it was 6. So 6 plus 12 will be what? So you can say capital T is equals to 6 plus 12 is equals to 18 seconds. Right? So this is how you have calculated your value of t. So I hope you understood. With this, the question will end, and in next video we will continue use of calculus, which is lesson 3. Thank you so much for watching the video. Please press like and subscribe button and share it with your friends. I would appreciate your positive comments. Thank you so much. Take care. Allah Hafiz.